Hey there! Are you ready to take your calculus game to the next level? Buckle up because today we're diving into the fascinating world of definite integrals. Trust me, it's cooler than it sounds. First things first, what even is integration? Think of it like finding the area under a curve. Imagine slicing a shape into an infinite number of tiny rectangles, then adding them up. That's integration in action. It's often referred to as the opposite of differentiation. While differentiation breaks things down into rates and slopes, integration puts things back together to find areas, volumes, and more. Here we have the basic rules of integration. We have the following, which are power rule, exponential, constant multiples, absolute value, sums, and differences. These rules will serve as our guide or foundation when it comes to solving. And you may ask, what is the purpose of that C? Well, that C represents the constant of integration since any constant differentiates to zero. If f of x is a function defined on an interval a to b, the definite integral of f from a to b is given by this formula, provided the limit exists. If this limit exists, the function f of x is said to be integrable on a to b or is an integrable function. This basically means that definite integrals are integrals that has specific upper and lower limits resulting in a numerical value. Definite integrals differ from indefinite integrals in a way where indefinite integrals lack limits resulting in a family of functions with an added constant of integration. The integration symbol is an elongated S suggesting sigma or summation. On a definite integral, above and below the summation symbol are the boundaries of the interval a and b. The numbers a and b are x values and are called the limits of integration. To be specific, a is the lower limit whereas b is the upper limit. We call the function f of x the integrand, and the dx indicates that f of x is a function with respect to x, called the variable of integration. Let us now proceed with the sample problems. First problem we have here, find the area under the curve y is equals to 2x from x is equals to 1 to x is equals to 2. First thing to do here is to set up the integral, which is, in our case, is integration of 2x dx from 1 to 2, where our a is equals to 1 and b is equals to 2. Now, reminding you guys again that our a is our lower limit and our b is our upper limit. Next thing to do is to find the antiderivative. In finding the antiderivative, we'll just have to integrate 2x dx, which will give us x squared plus c, following the rules of integration. Now, using the antiderivative, f of x is equals to x squared with c is equals to 0, we will use the following formula for area under the curve, which is a is equals to f of b minus f of a. To do that, we'll simply have to substitute the values of the limits, upper and lower, and get the difference of it. Now, substituting it will give us this, and evaluating further, we will have 4 minus 1 plus c minus c. Combining like terms, it will give us the following, which is our final answer, which is area is equals to 3 units squared. Next problem here we have to find the area under the curve y is equals to cosine x from x is equals to 0.5 to x is equals to 1. Now, just like the previous problem, we'll do the same steps. First is to set up the integral, which is integration of cosine x dx from 0.5 to 1, where our a is 0.5 and b is our 1. Now, let us find the antiderivative. In finding the antiderivative, we'll have to integrate cosine x, and according to trigonometric rule, cosine integration of cosine x is equals to sine x plus c, which is now our antiderivative. Now, using the antiderivative, f of x is equals to sine x plus c with c is equals to 0, we'll substitute our following limits. The following limits, which now gives us sine 1 plus c minus sine 0.5 plus c. Evaluating further, it will give us 0.841 minus 0.479 plus c minus c. Combining like terms, it'll give us the answer of area under the curve is equals to 0.362 squared units, or unit squared. Lastly is this problem. Evaluate integration of 12x cubed minus 9x squared plus 2 dx from 1 to 6. Now this is kind of different from the other two problems since the integration is already set up. So we'll just have to skip to that first step and proceed to finding the antiderivative, which is 3x to the fourth minus 3x cubed plus 2x from 1 to 6. And substituting the limits, substituting the upper and lower limits, we get 3,888 minus 648 plus 12 minus 3 plus 3 minus 2. And evaluating further, it'll give us the area of 3,250 units squared. That is it for our sample problems, and let us proceed with the assessment. And there you have it. Integration doesn't have to be scary. It's just about breaking things down step by step. Practice a few problems and soon you'll be a pro at integration. If you enjoyed this video, be sure to give it a thumbs up, subscribe to the channel, and hit that bell icon for more math content. Until next time, happy integrating!